All right, so let's talk about something every developer runs into. You're building software, it's growing, and that growth can be a real double-edged sword, right? More features, well, that can just mean more complexity, more chaos. Today, we're going to dive into the core ideas that bring order and security to even the biggest, most complicated projects. Let's get into it.
I mean, this is the big question, isn't it? When you've got hundreds, maybe thousands of files, and a whole team of people all working together, how do you keep the whole thing from just collapsing into a tangled mess?
So this messiness, it really comes down to two major threats. First up, you've got name collisions. What happens if two different programmers both create a class and call it date? How does the system even know which one you mean? It's total chaos. But the second one, unprotected data, that's way more dangerous. If you don't lock down your critical information, it can be changed or corrupted by anything, and that leads to disaster.
Okay, so let's tackle that first problem, just keeping things organized. The solution is something called a package. And honestly, the best way to think about it is just like a filing cabinet for all your code.
That's really all it is. At its heart, a package is just a folder. You group related code together. Everything for payments goes in a payments package, all the user profile stuff goes in a users package. It gives you a clear, logical structure that anyone can understand.
And the benefits here are huge. I mean, besides just being organized, packages completely solve that name collision problem we talked about. Now, you can have two date classes, no problem, as long as they live in different packages. One can be java.util_date and the other java.sql.date. See? The package name is kind of like a last name. It makes each class totally unique. And notice that third point there, access control? That is a perfect lead-in to our next big idea.
Because you see, packages give you that first layer of organization. But to truly protect our data from being messed with, we need an even more powerful principle. It's called encapsulation. And you can think of it like creating a digital safety capsule around your most important code. This analogy is just perfect. When you drive a car, the designers give you a really simple interface, a steering wheel, a couple of pedals. They've encapsulated that entire complex engine. They've hidden all the complicated, dangerous parts so you can't just reach in and break something by accident. Well, good software should work exactly the same way.
Now, to see why this is so critical, let's imagine we're building a banking app, and we make a really common but really dangerous mistake. We decide to make the account balance public.
Just look at this little line of code. The killer word here is public. That one word means that anyone, any other part of the program, can see and directly change the value of that balance. It's like leaving the key to the bank vault just sitting out on the front counter for anyone to grab.
So what happens when some other part of the program decides to mess with this account? Maybe it's a piece of malicious code, or maybe it's just a simple bug somewhere else.
And boom, there's the attack. Because the balance was public, this other code can just reach right in and set it to negative 50,000. That should be impossible, right? You can't have a negative balance in a bank account. The fundamental rules of our system are now totally broken, all because of that one little word, public.
So the solution is encapsulation. What it means is we bundle the data, like our account balance, together with the specific methods that are allowed to act on that data, like a deposit or withdraw method. And then, and this is the key, we hide the actual data from the outside world.
I love this analogy. The data, your balance, is like the powerful medicine inside. The class is the protective outer shell, and your methods are the only prescribed safe way to use that medicine. And the fix is a pretty straightforward three-step process. First, we hide the data. We change balance from public to private. It's now locked down. Second, we create a public deposit method to act as the official gateway. And third, this is crucial, we put a security guard inside that method. We add a validation check to make sure the deposit amount is always greater than 0. Now it's literally impossible to set a negative balance. Problem solved.
Now, this whole idea of public and private, well, that's just the tip of the iceberg. Most programming languages actually give us 4 different levels of visibility to control exactly who gets to see what. So let's break them down.
Okay, I know what you're thinking when you see this table. It looks a little intimidating, right? But don't worry. This chart shows you everything from the most restrictive at the top to the most open at the bottom. We're going to walk through each one with a simple analogy, and it'll all make perfect sense.
So, at the very top of the security ladder, we have private. Think of this as the bank vault. Only the code inside that exact same class can see or touch anything marked private. It is a complete lockdown. Maximum security. This should be your default choice for any sensitive data.
Next up is default. This is actually what you get if you don't type anything at all. Think of this like an office. Anyone working in the same office, or in our case, any class in the same package, can see and use it. It's perfect for helper classes that need to work together closely but shouldn't be exposed to the rest of the application.
Then we get to protected. Now this one's a little special. It's like default, so everyone in the package can see it, but with a twist. It's also visible to any child classes that inherit from this one, even if they're in a completely different package. So it's kind of like passing down family secrets. Only the immediate family and direct descendants get to know.
And finally, we have public. This is the billboard on the highway. Absolutely anything from anywhere in your entire project can see it and use it. You have to be really careful with public. You only use it for the official, stable entry points to your code, like our deposit method. It's the public promise you're making to the rest of the world.
So we've talked about packages for organizing our code and encapsulation for securing it. Let's just wrap this all up and look at the real-world payoff. Why does going through all this trouble actually make our software better and safer?
The payoff is just immense. By hiding your data, you get total control. You can decide if a value should be read-only, for example. You enforce validation, which stops bad data from ever corrupting your system. You get flexibility. Remember the car engine? You can completely change how the engine works on the inside, but as long as the steering wheel and pedals don't change, no one who uses it will ever know the difference. And ultimately, you get security. You hide the complexity and you protect your data.
And just think about that for a second. Every single app on your phone, your banking app, your social media, all of it is built on these exact same principles. They are the invisible rules that are constantly working to keep your private information safe and keep the software you rely on from falling apart. What do you think our digital world would even look like if they didn't exist?